share the screen. Let me get my chat up. All right. So what I want to do today is I want to look at Kubernetes. We looked at containers and we looked at Docker and how you would use containers. Containers are very popular in the cloud, and they're very popular for a whole bunch of different reasons. They're more and more used as security devices or privacy devices, ways to transmit information without showing the actual information itself, but you can work on it, but through a container that wraps everything in secrecy. But in the cloud, because of the popularity of running things with containers, particularly for managing what you're doing with all the VMs, the containers where they are, there's some systems that have arisen to make this easier to do. And in fact, that's why I gave you one of the assignments that I did where you were, starting up VMs and putting containers there and all of that to show you how much work you might have to do if you don't have a tool to help you do it. And so one of the tools that currently is fairly popular is called Kubernetes. It's actually, Kubernetes is Greek for helmsman or pilot. And it is a product of Google. They open sourced it. So there's lots of different versions of it around. It's usually free to get. It's written actually in Go, which is a very popular language for writing a lot of systems things in the cloud. So it's something to look at. And like I said, it's open source. It's under the Apache license. There's lots of different versions around that run on all sorts of different things, not just in the cloud, but it's very popular in the cloud. So we're going to look at this to get an idea of what you can do with this. So as I said, this is a Google product. They started with a project called Borg. And that was something that would help them run their services like Gmail and search and other things because they had to organize all of their servers and the containers on them and everything like that. And then they realized, well, this is actually a really useful product. And they decided to open source it, which was very nice of them. And so mid-2014, they released Kubernetes. Now, Kubernetes is not the only game in town. So there's lots of other container management systems that are out there. The most popular, aside from Kubernetes, is called Docker Swarm. And there's lots of people that prefer Docker Swarm, and we'll talk a bit about this when we look at the disadvantages of Kubernetes. But you get a lot of people out there that have been reluctant to change from Docker Swarm to Kubernetes, but they may have to because there are some noises out there that Docker Swarm may not be with us forever. So they seem to be losing out a bit to Kubernetes, but there's also all sorts of other ones out there. So you're not limited to just this way of managing things. But I want to use Kubernetes as an example of what you can do with these types of management systems, because now what we're looking at are what people are putting on top of cloud. So you've got all the different things that the cloud platforms provide, but now there's another layer, and these are all the things that either one of the clouds themselves or third parties put on top of cloud. And so even though this was done by Google, in a way, it's still similar to the idea of like Docker Swarm or any of the other third-party ones. Because Google released it open source, it's more like a third party than it is. It's not just for GCP. So what is it? It's a container management system. So the idea is that if you are running a very large system where you have multiple different, let's say, applications or pieces of applications out there that have to run on all different types of systems, get access to all sorts of different resources, scale up, scale down, do all sorts of different things, you need a system to manage that. And one of the things that people have looked at for management, the first thing is containerization. So we went from the idea that cloud was born out of virtualization. You couldn't have cloud really without virtualization. But now virtualization has morphed into another version of it, another dimension of virtualization, and that is the container. And so we went from having VMs and virtualizing the entire operating system to having containers that virtualized only a part of a system. And now what we're looking at is that you may be running your entire operation, your entire system via containers. And you may want to be putting these up in all different various places. So either physical, virtual, cloud environments, whatever, all different places you may be wanting to organize where your containers are. And so Kubernetes is a very flexible container tool that lets you do all sorts of things. This is one of its downsides. It's so large and so flexible and so complex that some people are a bit put off by it because there's so much to learn to run Kubernetes. But it does allow you to manage something that's very complex. It allows you to get consistency in your management of this complexity. So the thing that Kubernetes is trying to do is say, you want to present outwardly to the world the same face all the time. So you want all of your different containers working. You want them all in the same version. You want everything consistent. Right? Even though we know things happen in the background, stuff goes bad, stuff breaks down, things have to get updated, all sorts of things happen. But Kubernetes is there to automate the management of this environment so that it looks consistent to the outside world. So what are some of the things that it allows you to do? It will automate scheduling of containers of various processes starting up and doing all sorts of things. It will auto scale and do some load balancing. It will automate rolling out software or rolling back parts of your system. It's enterprise level software. So this is not something that somebody hatched in a garage kind of thing. This has lots of enterprise features. It is fully featured. It has lots of different things to it. It's application-centric management. In other words, what it's letting you do is not just concentrate on the infrastructure management, but actually concentrate on the applications management. So you're managing infrastructure things, but you're doing it from a viewpoint of an application. So you want your application working, and this is how, this is the viewpoint that Kubernetes is giving you. And the other thing that's really great about it is has what's called self-healing. So in other words, if something goes wrong, if something stops working, it will do something to heal that, that problem. So let's look at the architecture for Kubernetes. It's not that complex, but it has a number of pieces. So if we look at this image, and at the end of these slides, I have some links to some really nice tutorials. And I think this one I took from, there's one where it's basically Kubernetes through pictures. Because Kubernetes has a lot of pieces. And so it does take you a while to learn everything about Kubernetes. But with this just gives you an overview of the different pieces that are there. So if we look at, you know, the top part here where we have the developer, the operator, what they're attached to is what's called the master node. And we'll look at this, and it has various pieces. And it's basically you are sending commands through an API server into the master node. And it will take care of all sorts of scheduling and different things like that. And it's talking to a bunch of worker nodes. So you have various worker nodes here, and that's what the user is going to be interfacing to. They're going to be interacting with the worker nodes. They aren't going to be looking at the master node at all. And so the worker nodes themselves will be talking to the master node, and the operator can see what's going on and you know, look at status and monitoring and things like that. but this is where all of the work is being done. And we'll also see that you really do have two separate systems here, the workers and the master. And we'll see when we look at how some of these services are rolled out with the public clouds. Sometimes what they do is they give you the master for free. In other words, they take control of the master and you don't really set it up or do a lot of work with that. You communicate with it, but they sort of run it. And then you're really just instantiating all these different little workers. So what do we have in the master node? So it's going to help you manage workloads and communication across the system. And so it's going to get commands from a command line interface or a GUI or some sort of user interface where the interface will send an API call to the master node. And a lot of times when you're setting up things for the master node to read and to do things, you'll often set up a whole bunch of things in a file. The language that's usually used for most systems in Kubernetes is YAML, but you also have third-party systems that sit on top of Kubernetes that give you a way to talk to it in a little bit more controlled, maybe a simpler manner than native Kubernetes. So what does it allow you to do? If you're talking to the master node, you can define pods, and these are the containers. Replica sets, in other words, you can have multiple pods that are identical, and the various services that you want to provide via these containers. It can also provide all the parameters for the applications that are running in your cluster of pods that will be contained within one of the workers. So if we look at sort of a stylized view of what the Kubernetes master is, you've got here some form of communication, whether it's through a command line interface or a user interface, GUI, whatever. And like I said, this may be via something that comes with the native Kubernetes installation, or it may be provided by a cloud provider, or it may be from a third party. It talks to the Kubernetes master, and the Kubernetes master really has three components that you really need to understand: a scheduler, a controller, and this thing, ATCD, or the key value store. And we'll see why we need a key value store later. But that's what's in the master. So the key value store is a database, and it's storing all the configuration and state of the cluster. So the nodes, the pods, the containers, all of that. It's containing all that information. And what's really important with this is when we get to the stage where you want to actually do some self-healing. So in other words, you want to replace a pod that's gone bad or a node that's gone bad. The key value store keeps all the information so that you can replicate and put in another pod, and the system will actually have all the information it needs to actually slot in that new pod in a way where you won't even realize that it was done. You won't know, like there won't be any difference between the pod that went bad and the one that's in there. You have the API server, obviously that's just the front end, so you can, the master can talk to who's ever setting up a system. With the scheduler, it will take requests that come in and assign whatever is, like whatever container or task has been assigned, that has been requested, it'll assign it to a healthy node. And so the scheduler has to understand what state various nodes are in so that it can assign containers to these nodes. And it gets that from the controller manager that checks the states of all the different nodes against the desired state that they should have and resolves any differences. So in other words, if something starts going bad with the health of a node or a pod, the controller will will notice this, and it will then be talking to the scheduler and to other parts of the system to figure out what to do about the situation that it's found. So it has basically something that monitors what's going on with all the other nodes in the system, basically the worker nodes, and the scheduler is taking requests from the person who's managing the system, or this can be automated where it's saying, okay, now we have to start something else working. We have to put it out on the system. We need a node to put it on. Where can we put it? And how can we do this? Now, we come to the worker nodes. So these are the ones that are doing all the work assignments from the master node. So the master node is just organizing everything that's going on in the system. And that's why when we look at the public platforms, you'll notice that a lot of them say, oh, well, you don't even pay for the master node. Well, it really is, you don't pay for the master node because they're sharing everything, like they're controlling all the master nodes. So the worker nodes are really where in any of the systems you're going to be, this is where the work's done. So this is where you're going to be charged. This is where you're going to have to make some decisions about what those worker nodes are. So they execute the work assignment and report back to the master node, and they make sure that the master, there's this communication that goes back and forth between the master and the workers, so that the master knows what the health is of the worker and the worker knows what the master wants it to do. And the workers have all the services to manage the networking between containers that it has. So the nodes will have containers within them in these pods, and it will work with all of those containers. So it will make sure that if the container has to speak to anything, it will provide all of those services. So if we look at, once again, a stylized image of what is in a worker node, you can see that the worker node itself is connected to the outside world. So it can be connected to the internet. So it will have a network proxy or a kube proxy. And with this system, that allows it to do all the networking for any of the containers. There'll be a runtime system, and there'll be these pods, and there'll be this kubelet that controls what's going on in the system. So if we look at the kubelet, it's the primary agent. So it is controlling and monitoring all of the nodes, CPU, RAM, storage, so that it's basically putting this node into the Kubernetes system. And it executes tasks and reports back to the master. So, and with this, because it's reporting back to the master, it's the communicator to the master, it's going to monitor the health of the pods. So if something goes wrong with any of the, and these are the containers basically, if anything goes wrong with any of the containers, they stop working, or they're throwing out errors or something like that, which can happen, they monitor that and they send it back, the reports, to the master. So the master can know what's going on in the system. The kube proxy, this is how the containers are going to talk to the rest of the world. They have to get access to the internet. So this is going to control the IP addresses. And it'll have local IP tables and rules to do routing and traffic balancing between all of the parts of the node. This is what's going to actually make it look like those pods always exist. So the pod will get an IP address, and like that container, and you're gonna be able to get to it through this IP address. So this is the connector. This is the proxy that is going to connect the interior of the worker node to the rest of the world. And this is actually where this etcd table comes in, because one of the things that you have to make sure is that these IP addresses are stable. You'll also have this container runtime. It's going to be pulling images from an image registry, and it starts and stops the containers. So this is actually usually done with Docker. So even though to a certain extent Docker Swarm has been replaced by for some things with Kubernetes, it's still dependent on Docker for the most part. Docker isn't the only container system out there, and I believe with Kubernetes, you can probably reconfigure it to not use Docker, but for the most part, the container runtime is going to be Docker. And this is controlling all the images. And then the last unit is the pod. So this is the smallest element in Kubernetes. And this obviously is also one thing that can be scheduled. It's a wrapper for a single container. So a pod and a container are virtually the same thing, but the pod is the wrapper around the container that allows it to communicate with the Kubernetes system. The master will schedule a pod on a specific node, and then it will coordinate with the container runtime to launch the container. And if a pod fails, then it's replaced by a replicate. And that pod is identical, right? It's the same container. Everything is identical, except it wouldn't have the same IP address. And that is a problem. And that's why we have that key store. So what are the various services? What does Kubernetes give you? Well, one of the big things that, like I said, that Kubernetes gives you is this consistency. So in other words, if you have various components that are there, various containers, pods, whatever, they have to be there. They have to be reachable all the time in the same way. So one of the big tasks for Kubernetes is to make sure that pods that stop functioning are replaced. And replaced automatically. So even though obviously a person may be monitoring this system through the master node, they don't have to look at it and say, oh my goodness, these pods have failed, I have to replace them. Kubernetes will do that automatically. And so the service will provide this replacement, but it also brings stable IP addresses and DNS name services to the pods. So this is the issue that they had when they first started this, is that when they kept replacing things, like, okay, shut down this pod, put out another one, shut down this pod, put out another one. The problem was that it kept getting assigned different IP addresses. You were just running through all these addresses. What you want to do is you want to keep the same IP address. You want to transfer it to the new pod. And that's what the service does. So there's a stable networking endpoint. So you have a fixed IP, DNS, and port for each pod. And so if the pod dies, it fails, and a replicant is put in its place, it really is like it's put in its place, because the pod itself is replaced, but it still has that fixed IP and DNS entry and everything like that. So, and all the ports, everything is the same. So that is done because the pods are associated with these services through these key value pairs. So there's labels and selectors in these pairs, but that's what is kept by the master. So the master is keeping track of all of these, all of the stability elements for Kubernetes. So that when you look at the Kubernetes control panel, it's going to record and implement and run background, and they call them reconciliation loops. And they constantly are checking to make sure that what you said you wanted in your environment is what you're getting. So it's constantly looking through and making sure all of this is consistent and continuous on through all of the nodes and all of the pods on all of the nodes. Now, what are some of the advantages of running Kubernetes? Because you've seen, you could do a lot of this yourself. There are monitoring programs. There's all sorts of other things, or you could run Docker Swarm, or there's a whole bunch of third-party systems out there. You could write your own code to look at. It's not beyond the realm of possibility you did part of this for an assignment. But what are the advantages of this system that Google has set up? One advantage, it runs on everything. All of the public cloud platforms has a version of Kubernetes. OpenStack, if you're rolling your own cloud, it has Kubernetes. Anything can run Kubernetes. You can run it on your laptop if you want. Everything can run Kubernetes. It actually helps you with vendor lock-in because it is so available everywhere, because it's open source, and because it's really working through a series of APIs and services. It is actually pretty easy to move your setup from platform to platform. So you don't really have vendor lock-in per se, because there is the notion of Kubernetes compliance. So if you go from one system to another, so if you're moving from, let's say, Azure to AWS or Azure to Google, their Kubernetes will be compliant, and you should be able to very easily transfer what you're doing on one Kubernetes system to another. It's obviously helping you with containerization, and itself is containerized. So this whole notion of these of virtualizing everything is part and parcel of Kubernetes. It automates all the processes of distributing, starting, managing containers across all sorts of different cloud architectures. And I'm sure that you found that the part of that assignment, what was it, assignment 2, the part that was so challenging was not in starting up all the VMs and even finding out what the VMs are doing. Most of that is fairly straightforward. What was a little bit harder was managing the containers and starting them. So that was what was harder, because it actually had to deal with whatever you were starting the containers on. So there was a lot more to know than there was to just starting up VMs. And there is a consistency that you can set up with Kubernetes, in that you can set up Kubernetes so that your development, testing, and production environments are all the same, are all done the same way. And so it's very easy to automate all of this so that you can go from development through testing to production very easily with your setup for how you are going to instantiate and distribute and manage all of your containers. So if you're doing your development via all of these containerized pods, you can use Kubernetes to manage the whole development process. And a lot of people too run other software or run it through GitLab. There's all sorts of different things that you can interface to Kubernetes with. Just in its design, it's very loosely coupled with the components and the infrastructure. That's why it's been fairly straightforward for Google and for other people to port it from Google, from the open source. So it's not impossible to work with the system, to put other flavors of it together, to put other things in, and people have done that. There's people have used it as a base for a lot of different things. It has a high density of resource utilization. Obviously, it's managing everything, so it actually can be very, very efficient with what it's utilizing. It is version control in that each deployment is versioned. So it actually has built-in version control, and that's why it's actually great for when you're setting up a production system where you're going from development to testing to production. It's all set up for doing that. And like I said, there's many third-party tools available. One that I've worked with is called Rancher. And basically it's a way to help you set up Kubernetes. It's not open source, but it is free, except if you want help. It's one of these ones where the product is free, but the help is not. So for the most part, most of the third-party add-ons to Kubernetes are free. You just probably have to pay for the help they give you. Now, what are the disadvantages? There's got to be some disadvantage, and the first one is the big disadvantage: complex. It is complex. It's big. It's many. There's many features. You have tons of courses out there to step you through every single part of Kubernetes. and how to manage containers, how to develop them, how to put them, how to organize them and do everything. So it's a very powerful tool. And with power generally comes complexity. So you'll have a lot of people when you ask them, you know, like they're using containers and they've got their system out there and it's on the cloud, and you say, so are you managing it with Kubernetes? And they're like, oh God, no, I'm using Docker Swarm. And so people who have set their systems up with Docker Swarm, it's not so much that they're in love with Docker Swarm, they just know it, it's simpler, and they are afraid of moving to Kubernetes. Now, some of the fear is a little bit manufactured in that you can set up Kubernetes fairly simply, but because it allows you to do so many things, you can add and add and add to Kubernetes, so it can start to become very complex. Obviously it lets you manage complex systems. So obviously if your system is complex, it's going to take some self-education to figure out how to make Kubernetes work for you, but it's got many features. The other thing that is a bit of an issue is potentially is security. And so this isn't sort of like it's a given that, you know, like tons of Kubernetes installations have been broken into, but the thing is that there's not much known about the security of Kubernetes. And so that can be a little bit of an issue that probably will be better served in the coming years. As more, this is the most popular container management system, and because of its open source and because it's out there so much, we'll know more and more about the security, because more and more systems will be managed by Kubernetes, and the more you have out there, the more people attack. So that's sort of a continuing story. The first thing that people are really worried about is complexity. And I don't want to say it isn't complex. You will, this is not something you set up in an hour and say, oh, that's it, I'll never have to look at that again. It'll take you hours just to figure out what are all the things that you could do and might want to do. So if we look at container management in the public cloud platforms that we've been looking at, in a lot of them, what you'll see is that they, excuse me, may have more than one way to manage containers. And usually what they have is that they have Kubernetes and they have a simpler one. So if we look at Azure first, we have a service called Azure Container Instances. And so with this, you can run a container in Azure and you don't have to manage the virtual machine. And you don't have to do very much with this. It's basically, there's a service there to manage containers. And this is where maybe what you want to do is just operate an isolated set of containers, maybe a simple application, some task automation, maybe some builds where you're just trying to build something, a system. So this is the simplest sort of way in. So you don't have to do very much. So you don't even have to manage any virtual machines. You just use their service for in running a container image. And so this might be all you need. So with all of these different platforms, what you need to do is you need to go through and you need to figure out what you need and what your requirements are and how many resources you can put behind this. And when I talk about resources, I'm talking about human resources in managing this system. So if we look at Azure, like all of them, it has your entry level container management. And then they have their full Azure Kubernetes service, AKS. And so this is what they call a hosted Kubernetes service. It handles, so Azure itself handles the critical tasks like health monitoring, maintenance, and the master. So the masters are managed by Azure. And so you don't pay for the master, you pay for the worker nodes. Right, so you're paying based on how big and complex your system is, but you're not necessarily so for a simple system, you don't get dinged, or a small system, you don't get dinged for the master as well. They manage all of that. I've got some, for all of these, I've got links. So if you're interested in, or at any time have to set up a Kubernetes system, I've got links to not just tutorials and information about Kubernetes itself, but on various services for the 3 different platforms. So if we look at these diagrams that I took from Azure, from the references, basically what they're telling you for their AKS system, this part of it that has the control plane, the scheduler, the key store, all of this, the scheduler, the controller, everything like that, that is all provided and managed by Azure. Okay, so you don't have to do anything with this except use it as a service. And this is what you manage. So you manage the worker nodes, right? So that's what you're setting up. That's what you're doing. And so basically in this system, you have, when you set it up, like when you go and use Azure AKS, when you use AKS, what you're doing is that you're going to be generating virtual machines to have the worker nodes on. And so it will, when it's setting it up, it's going to be asking you about, like, do you want Linux? Do you want Windows? And basically you're going to be, this is why you pay for this part, because you're actually going to be putting it up on a virtual machine. So contrast it with the simpler view of container management, which they're saying, oh, you just want to run a container to do something, or 1 or 2 containers to do a simple task. Just go through our container system. Don't worry about a VM. It's sort of like a serverless function. Just do it. We'll give you a service for that. If you actually want to run full-on Kubernetes, they will let you do that, but they are going to take care of the master node, and you will be managing and designing the worker nodes. And you're also going to be paying for the worker nodes. So I've got some references if you want to go through, learn how to look at, to use the container instances, and then any of the, if you want to use the Kubernetes, the AKS system, I've got some links there where it explains, as an introduction to Kubernetes, it explains how they do it and how you can set it up in Azure. AWS has all sorts of different options. It has lots of options that they tell you about. And in fact, you could do this on, the first one you could do on Azure as well if you really wanted to, but AWS says, well, you can run your own. They don't care. Kubernetes is open source. Go get your own code and run it. They don't care. So you could do that. You set up a VM, run Kubernetes. They don't care. That's what you're doing. So that's totally you. So that means, they're looking at this about how much work you have to do. That, they're saying you want to do all of it yourself, go ahead. You could do that on Azure if you wanted to, why not? They also have EKS, which is the Elastic Kubernetes Service. So this is very much like we saw with Azure. You can run Kubernetes, but you don't need to provide or manage the master nodes or the key store. So it's just like AKS, you have EKS with that. They also have the Amazon Elastic Container Registry. So this will store, encrypt, and manage container images so you can deploy from there. It is a fully managed Docker container registry, and it will store, manage, and deploy Docker container images. So if you want to just have a very fast way of instantiating and storing and managing your containers, you can do it, the container images, you can do it through ECR. And they have something very much like Azure had too. They have their Elastic Container Service, which is fully managed container orchestration service. So basically, if you want to just put out containers, it will do that. So it's very, so what Amazon has and what Microsoft has, very similar. They're, the only thing that's a little bit different is this ECR option that they have, but they both have like a container service. They have full Kubernetes where they take care of the master node and the key store. And technically, you can always spin up a VM and do it yourself. So they have that. then if we, so if we look at that, sorry, with EKS, it's fully managed. One thing is compliance or conformant to Kubernetes, so it's certified. The nice thing about this in why this is an advantage over doing it yourself, like just running it on EC through EC2, is that the control plane can run across, so the master can be across multiple availability zones. It can do, once again, it's going to give you this service of being able to spread out everything over different regions and zones so that you don't have a single point of failure. So very much a cloud approach to things. So they're taking advantage of the fact that they have this large distributed system, geographically distributed system, and they're using that for fault tolerance. Now, one of the things that you can do with EKS, you notice on the Azure one, when it was saying you were using their Kubernetes service, you would have to tell it what VM you wanted the workers on. With the Amazon EKS, you can also choose to run AWS Fargate, which is a serverless compute for containers. And so just like you were using Lambda functions, Fargate allows you to run containers without VMs. So you don't have to provision and manage servers, so you don't have to pay for them. And you specify and pay for the resources per application. And they're looking at this as being a little bit more secure because, once again, they're doing more work here. So if you were using if you were just using virtual machines themselves are obviously they have insecurities. There are attacks. They're no different from any computer. They can be attacked. Whereas with the serverless compute, what you're attacking is AWS. So when you're attacking a VM, you're attacking whoever is running that VM. You have some layer of protection by the cloud provider. But remember, when you set up a VM, you can set it up to do almost anything. You can be as insecure as you want. You can open up all the ports. You can do all sorts of stuff. You can load terrible software on it. You can do all sorts of things. So it is more secure if you allow the cloud platform to do more of the security, and they can do more of the security if they're controlling where everything is running. And so that's what you get with Fargate. So it's basically a serverless option for running containers, and you can do that within Kubernetes. So I've got a bunch of things here where you can go through, and there's all the different explanations and services that that AWS offers. And then obviously you can go to the source, you can go to Google. So if we look at Kubernetes on the Google Cloud Platform, it's called GKE. And so, I've given it just some URLs for going to that to learn about it. They've got a whole bunch of different things, use cases, documentation, all sorts of things to find out about their compute engine. And they have a very nice little sort of tutorial guide to step through so that you can deploy containerized web applications. So it's really nice to work your way through that. And to be honest, it's a nice way to work your way through, even if you aren't going to use Google. It gives you an idea what you would do when you're setting up a containerized application running through Kubernetes. So something nice to look at. And so I've given you links to those. So particularly when you can look through the tutorial so that it can get you up and running with a simple app. It's kind of fun to do. And then I've got just a couple of simple guides to Kubernetes. As I said, like this is like a little tutorial. This is Kubernetes in 10 minutes. And this is basically understanding Kubernetes through pictures. If you just want to get an idea for what Kubernetes is and how it works, they're a good place to start. like I said, there are courses everywhere that you can take, not just through the cloud providers, but there's tons of different services, different people that are doing Kubernetes courses. Some of them they're quite intense. There's lots of different features, different ways to control, different things you want to control. So they're not a bad start if you ever get into a situation where someone wants you to manage, set up and manage a Kubernetes based system. But there are also these shorter ways where you get an overview, and then, like I said, there's third parties where sometimes what they do is they're directly controlling Kubernetes for you, like Rancher, and sometimes they're allowing you to design your system, and then you can push that off to Kubernetes, because I think Terraform is like that, where you're basically, it's almost like a programming language to say what you want the system to do, and then that can be run by Kubernetes. So there's lots of them out there. I just mentioned like one, there's tons of them out there. So let me get back here and share. I'll stop sharing. Okay, so yeah, with Kubernetes, it's always an interesting thing to play with and look at, and it's always something interesting to consider when you're trying to design and implement a large system. And just thinking about that exam question that I gave you, when you're thinking about that, this might be, one thing that you would be actually considering doing is orchestrating a lot of the services via containers, and you would be controlling those containers and maintaining their health and making sure they're there with something like Kubernetes. So, all right, I'm going to stop